Good morning, dear students. Today we will discuss on discrete time samples or discrete time signals. And here is the question. The question is like this: the discrete time signal x of n and y of n are shown in the figure respectively. Sketch the signal z of n is equal to x of 2n into y of n minus 4. And this is the given data, and these are the two given sketches, x of n and y of n they have given. We need to sketch x of 2n and y of n minus 4, and then you have to multiply both the signals. So to this signal we just multiply 2. That's if you are going to multiply, it will compress, the signal will be compressed. If alpha is greater than 1, the signal will be compressed. If alpha is less than 1, signal will be expanded. So in this case alpha is greater than 1, so hence the signal will be compressed. You just have to divide the time scale by 2. Minus 3 by 2, if you divide minus 3 by 2, you will get 1.5. You compare with the original signal. If you compare, you will come to know there is no signal existing at minus 1.5. So that is why this signal will be eliminated. Next, coming to minus 2, if you divide minus 2 by 2, you will get minus 1, but at minus 1 there is a signal existing. Signal is existing at minus 1. So this signal will remain as it is with amplitude. Look at this. At minus 1, the same signal is shifted to minus 1. At minus 1, we need to show that the same signal, that is, which is having an amplitude of 2. Next, you divide it by minus 1 by 2. You divide by 2. Now you will get 0.5. At 0.5, there is no signal existing in original signal. Hence, this signal will also get eliminated. So only at minus 1 there is existence of signal. Next, coming to 1, 0 there is no signal. At 1, again divided by 2, you will get 0.5. So 0.5 there is no signal existing at original in original signal. Hence this signal will be eliminated. Next, at 2, you divide it by 2, you will get 1, but at 1 there is a signal existing. So this signal is shifted on 1. Look at this, at 1, and its amplitude will remain as it is 2. Now divide 3 by 2, you will get 1.5, but at 1.5 there is no signal existing. So this signal will get eliminated. So I am solving this problem with respect to discrete time signal definition. So you cannot define all the signals at all the instants of time. That is what the definition of discrete time sample is. In case of continuous time signal, you can define all the signals at any instant of time, but here it is not possible. So next operation is y of n minus 4. Y of n minus 4 means it is a right shift. Look at this, n minus 4 is equal to 0. So n is equal to plus 4. So if it is plus 4, it has to shift it towards the right by 4 samples. With respect to this equation, or with respect to this sample, it is a right shift by 4 samples. You count it from this: 1, 2, 3, 4. So your signal will start from 0. Look at this. The fourth minus 4 signal will arrive at 0. When you shift the whole signal, the minus 4 landing point will be at 0. 1, 2, 3, 4. Why 4 shift? Because it is n minus 4. Therefore, the signal will start from 0, 1, 2, 3, and 0th position will be 4th, and 1 position will be 5, 5, 6, 7, 8. These are the two signals. One is x of 2n and y of n minus 4. Now next operation is to multiply both the signals. Here is the multiplication symbol. Dot indicates the multiplication. you multiply both the signals. You start it from the left side. So starting point of the signal, you just check out the starting point of the signal among two signals. So starting point of signal is at -1. Is there any signal existing at -1 in both the cases? At -1, in this case at -1, one signal is existing and whose amplitude is 2, and at -1 there is no signal is existing in case of y of n minus 4. So therefore, if you substitute in case of in place of x of 2n, that is 2, if you substitute 2, and at y of n minus 4 there is no signal, at y of n minus 4 there is no signal, at -1, so this will be 0, so you will get 2, so you will get 0, sorry, you will get 0. Next, at 0 there is a signal whose amplitude is -1. In this case there is no signal existing at 0, but in this case signal is existing but its amplitude is -1. So 0 into -1 you will get 0 only. Next, at 1 in both the cases you check out whether the signal is existing or not. At 1 there is a signal existing at x of 2n and whose amplitude is 2, and in this case at 1 the amplitude of the signal is -1. So 2 into -1, so you will get -2. That's what I have written at this place. Look at this. At 1 the amplitude of x of 2n is 2 and the amplitude of y of n minus 4 is -1. 2 into -1 you will get -2. So after that there is no signal exist, there are so no signals are existing. At 2 here it is 1, -1 and into 0 you will get -0. At 3 -1 here it is 0, so -1 into 0 you will get 0, and the remaining samples will disappear because in other case, in this case there is no existence of signal. That's why this is the only signal which is existing among the two cases, and this is the final result. Next problem is on the impulse function, that is x delta of n. Look at this. X of n, the given question is like this: x of n is equal to h of 3n into delta of n minus 1. H of 3n they have given. First thing, h of n they have given. This is the sketch of h of n, but we need to create or we need to sketch h of 3n. We just divide the time scale by 3. If you divide the time scale by 3, that is 4 by 3. If you 4 by 3, you will not get any signal which is existing or which is existing in original case, that is 1 point something you are going to get. So next, 3 by 3 you will get 1, but at 1 there is a signal existing. Look at this. This is -1, sorry. These are -1, -2, -3 and -4. You divide it by 3. In this case, -3 by 3 you will get 1, but at 1 there is a signal which is existing. So you shift this signal to 1 and your amplitude will remain same. Don't change the amplitude. Look at this. At -1 it is 3 by 2. Next, at 1 if you divide it by 3 you will get 0.3. So no signal which is existing in original case. So this will disappear. This will disappear. This and this will disappear. Only existing signal is at only existing signal is -3 by 2, which is at -3. Here also it is same. These signal will get disappear. 1, 2 and 4. Only 3 will existing. 3 by 3 will get 1. 1 there is a signal, and you shift this 3 by 2 to at 1. And here is the signal at 1, amplitude is 3 by 2, and next you sketch delta of n minus 1. Already we are having a basic signal, that is delta of n, that is the impulse function. The signal will be present at 0. Refer the basic signals which I have shared. This is delta of n, and they are asking sketch delta of n minus 1, and we are having delta of n. So you just shift the signal towards the right. N minus 1 indicates the positive sign. So if it is positive, it has to be shifted towards the right by one sample. 0 to 1. Now you start multiplying h of 3n and delta of n minus 1. If you multiply at 0, look at this, at 0 there is no signal existing in both the cases. So those signal will be 0 only. At minus 1, one signal is existing, that is the minus 3 by 2. That minus 3 by 2 into 0. In h of n there is no signal at minus 1. So this will be 0 and this is minus 3 by 2. Minus 3 by 2 into 0, you will get 0 only. So next at 1, there is a signal existing, that is 3 by 2 in case of h of 3n, and in delta of n minus 1 it is 1. Just multiply 3 by 2 into 1, you will get 3 by 2 at 1. This is what the example of discrete time sample or discrete time signals. Thank you.